Hello, my Math 30-1 students. How are we today? Woohoo! Okay, transformations. We're still working on transformations. Lesson number 5, and we're going to do lesson 5 and 6 in this homework assignment. We're looking at tonight, or today, whenever you're watching this, stretches about the x or y axes. Okay, so we've looked at so far translations, which is moving the graph left, right, up, down. Or reflections, which is where you take the mirror image of a graph over the x-axis, the y-axis, or the line y equals x. And now we're looking at stretches, which is literally what it is. It's where you're taking the graph and you're stretching it. And actually, you could be compressing it as well, which is stretching by a factor between 0 and 1. But anyways, for the sake of time, we're actually going to start on this page. Okay, so page 114. Please find that page in your workbook. Okay, and we're going to actually just jump in. Well, we'll see. We're going to jump into example number 1. They do a summary there, but I like to think of these stretches in a slightly different way. So I'll maybe summarize when we get through these examples for you. Okay, example number 1. Oops, too far. Okay, example number 1. Write the replacement for x or y and write the equation of the image of y equals f of x for after each transformation. So let's look at the first one. A horizontal stretch by a factor of 6 about the y-axis. Okay, so when you hear horizontal, that's got to be x, right? We're involving x in that. What that means is we're going to be replacing x with, we're doing the replacement right now. So horizontal stretch by a factor of 6. Now when we were translating and moving it left or right horizontally, we would add or subtract from the x, right? For the replacement, x gets replaced with x plus 2. That's moving it left 2. If we're stretching it, we're actually multiplying that x by a certain number. And remember how I said when it's with the variable, everything's upside down and backwards? Well, this is where the upside down part comes. So stretching by a factor of 6 means you would replace x in the equation with 1 over 6x. So we take that stretch factor and we reciprocal it. Okay, and that means then we're going to take our equation y equals f of x, and we're going to scoop the x out and put in our new x, which is 1/6 x. Okay, please don't think of that as just writing a 1/6 in front of the x. We're actually replacing x with a new version. Okay, all right, so now what will that do on the graph? Well, if we stretch by a factor of 6 on the graph, let's say we have a point at 1, 3. Okay, if we horizontally stretch about the y-axis, imagine a little rubber band tied to the y-axis, right? That distance from the y-axis right now, or the length of the rubber band, is 1. If we horizontally stretch it by a factor of 6, that distance would now be 6 from the y-axis, okay? And our new coordinate would be x equals 6. Y wouldn't change because we're not stretching or doing anything vertically. So that point would now be at 6, 3 if we horizontally stretch by a factor of 6. So that's the idea with horizontally stretching. Okay, let's look at the next one, a vertical stretch by a factor of 1/5 about the x-axis. Okay, so vertical, that means y is involved, right? So y would be replaced with, okay, and here's our stretch factor, 1/5. So again, we're replacing y, so it works just like the x. We're going to take that stretch factor 1/5, flip it around, so it's 5 over 1, or just 5. And that's what we're replacing y with. Y gets replaced with 5y in our equation. So if we write that, here's our old equation. Scoop y out, put in 5y, and there's our new equation right there. Now, sometimes they would like you to isolate for y. Up here they said write the equation of the image of y equals f of x after each transformation. They didn't really specify y equals, but if you did that, you would have to divide both sides by 5, which means you'd have like f of x over 5. Now, we don't usually write it like that, so what we would do, pretend there's a 1 in front of your f of x. We would write it as 1 over 5, 1/5, f of x. Okay, so now that 1/5 or that number is no longer with the y. Okay, notice that that number 1/5, same as the original stretch factor. That's the weird thing about vertical stretches. Once you get it away from that variable y, the stretch factor is now normally what it is. Okay, the number shows up as what it is. Can't do that with x because you can't, remove it from inside the f of x. Okay, so vertically on a graph, what does that mean? Let's take some point 1, 1, and if we're vertically stretching it about the x-axis, so the rubber band's tied around the x-axis, distance of 1 away, we stretch it by a factor of, oh, let's make this point a little bigger. I just realized we were stretching by 1/5. Okay, let's move that up to 1, 5. That would be a good one. Okay, now rubber band still tied around the x-axis, distance of 5 away. If we stretch that by a factor of 1/5, now stretching is probably a misnomer here. If we're stretching by a factor of 1/5, that means that distance of 5 would now be times by 1/5 a distance of 1 away. So are we really stretching it? Not in the literal words, it's more like compressing it really. So that point would now be at 1, 1. Okay, let's look at reflection in the x-axis and a vertical stretch about the x-axis by a factor of 3. So reflection in the x-axis, let's think about that. The x-axis, that would go down from here to here. So that means our y value is changing sign, right? So we're replacing y with negative y. Vertical stretch, so again, y is being replaced with factor of 3, so flip that, 1/3 y. So if you combine those two, overall, that would be y being replaced with 1/3, and it has to be negative for the reflection. And there we go. So in our equation, y equals f of x, we'd have negative 1/3 y equals f of x. And again, we could isolate y by multiplying both sides by, let's see, how would we get rid of that? A 3 would get rid of the 3 on the bottom, and negative 3 would get rid of the negative. So we multiply both sides by negative 3, we would have y equals negative 3 f of x. And there we go. Either one of those versions is fine. Okay, you guys try D, and then we'll see if we have the same answer. Pause your video, give it a shot. Okay, did you guys get y equals 1/4 f at 2x? Okay, replace x with 2x because the stretch factor is 1/2. Flip that to get the 2 in front of the x. Y is replaced with 4y because the stretch factor is 1/4. Okay, then replace them in the equation, isolate y, and we should get that as a final answer. Okay, let's look at the next example. Okay, example number 2. How does the graph of 3y equals f of x compare with the graph of y equals f of x? Okay, well, let's compare the two. We started with this, and now we have 3y equals f of x. Essentially, y was replaced with 3y. So if y is replaced with 3y, that sounds like a vertical, because it's y, stretch, because we're multiplying by 3, stretch by a factor of, okay, by a factor of, it's with the y, so we have to flip it or reciprocal it, so by a factor of 1/3. And you could add about the x-axis. In this course, we will not be looking at stretching about anything else but the x or the y-axis. And there we go. That would be our answer. Okay, so same idea on example number 3. What happens to the graph of the function y equals f of x if you make these changes? Replace x with 4x, y with 1/3 y, and then c, y with 6y, x with 1/3 x. Same idea. If you guys want to try those 3, and then we'll check and see if we have the same answer. Pause your video. Okay, let's compare. Replacing x with 4x should have been a horizontal stretch by a factor of 1/4. You reciprocal the 4. Replace y with 1/3 y, vertical stretch by a factor of 3, reciprocal the 1/3. Replace y with 6y and x with 1/3 x. So the y part, vertical stretch by a factor of 1/6, flip the 6. Horizontal stretch by a factor of 3, flip the 1/3. And there we go. All clear? So when it's with the variable, so 6 with the y, you always reciprocal that 6 or the coefficient to get the stretch factor. Okay, and that's when you're talking about replacing something in the equation. If we're talking points, it works straightforward, just like it did with translations. Okay, so let's take a look at example number 4. And I'm going to actually add to this example as well, since we kind of skipped a good part of the lesson. Okay, the graph of y equals f of x is shown. Okay, there it is. Sketch y equals f at negative 2x. Okay, now before you just start jumping into this, let's first recognize what we have and write down what transformations we have in what order. Okay, so first of all, when in doubt, the order in which you do transformations, and we'll get into this more on the lesson number 7, but would be SRT, stretches, reflections, translations. To remember that, just think of the word sort it out. Okay, so we have a 2 being multiplied by the x. Okay, that would be a stretch. And in particular, it's with the x, so that would be horizontal stretch. Okay, now you know what? They don't need to see this, so let's abbreviate it. Let's go HS, horizontal stretch. Okay, by a factor of, in fact, they don't need to see that either. By a factor of, what would it be? Flip it, we get 1/2. Okay, now negatives. You don't stretch by negative. What that negative is it's a reflection, if you recall from the last lessons, a reflection over, let's see, if x goes negative, that would be a reflection over the y-axis. And there we go. So we're going to do that to each point on this graph. And you can do it with the table of values if you prefer, or we can do it on the graph. And I'll show you both ways so that you can kind of get a flair for it. So first of all, let's go to this point here. So we're at -6 for our x value. Y is at 0. If we horizontally stretch by a factor of 1/2, that -6 would become -3. So you multiply -6 by 1/2. And there we go. Then you reflect it over the y-axis. So we're 1, 2, 3 away from the y-axis. So now we're 1, 2, 3 on the other side. And there we go. We'll erase that in between point. Okay, so that's now at 3. And then we'll do the same thing with this point and with that one. Now we could also set that up in a table. Let me show you how that would work. Okay, so you would have the point, the horizontal stretch by 1/2, and what the new point would be, and then a reflection over the y. Okay, so for the point, we'll use this next one, -4, 2. Okay, horizontally stretched by factor 1/2. Horizontally affects x, so we multiply -4 by 1/2 to get -2, 2, y stays the same. Then we reflect over the y, so x would go opposite sign. So instead of -2, it would now be +2. Okay, so you kind of have to picture it in your head too to get this straight. But all right, and if you want to do it as an image point, the point x, y then would become, let's see, horizontally stretched by a factor of 1/2. We've been multiplying the x coordinate by 1/2, haven't we, to do that? Okay, and when we reflected it, it went the opposite sign. So if we put a negative, that would be the image point going from x, y to -1/2 x, y. Okay, you guys do the rest of those points, get them plotted, and whichever way, use the graph or use the table. We'll see if we have the same answer, okay? Pause your video. Okay, how'd we do? Did we get the same graph? I've plotted the point, or listed the points too in the table, so you can kind of compare the exact value of the points, and hopefully we got the same graph. You can also, if you're given this image point transformation, or even if you develop it, you could pick any point like 6, -4, and actually put it, substitute 6 in for x in this thing, and the y in, and figure out that -1/2 times 6 is -3, -4. Okay, that's another way to use that. Okay, I have another part of this example that I've created, this one here. I want you to first write down what the transformations are, then plot the new graph. I'm going to pause the video, you guys do so as well, and we'll check back. Okay, let's finish this before we run out of time. So hopefully that red graph is the same as yours. One thing I wanted to point out is that there were points that didn't change. When we stretched horizontally, they were on the y-axis, and when we stretched vertically, they were on the x-axis. All right, let's go to lesson 4 in the next video. See you there.